All right, so this section is called the substitution rule. And so we're going to be doing some slightly more complicated integration here. And so this takes a little bit of practice to get used to how do you know what to substitute and how do you kind of manipulate these functions so that they look a little bit nicer and we can more easily find the antiderivatives. So, and this is basically undoing as far as where does this correspond in the derivative world. It kind of corresponds to the chain rule. So you notice in this one we have the square root of 1 plus x squared. That's one function. We have 2x. Here's the other function. And unlike, if you have two polynomials that are multiplied together, you can multiply them out and then take the derivative term by term. You can't do this here because these do not simplify in any other way. So we have to use what's called substitution. And so what we're going to do is we're going to identify the different parts of this. And so the one part we're going to look at is the 1 plus x squared. You don't really need to worry about the square root part right now. So don't worry about that. When you're identifying these pieces, you can usually it's more important that you identify the the more basic function here, not the square root doesn't matter. Um, the outside exponent, if you will, does not matter. All right, so we have 1 plus x squared and we have 2x dx. So we are going to let u equal 1 plus x squared. So the u is I'm gonna always identify this as blue, but obviously you need to know how to decide which is the blue and which is the red. I mean, you can't just say, well, the blue is in the middle, the red will be on the outsides. Doesn't exactly work like that. Um, but what you can do is pick the one that is the antiderivative of the other in some way. So if you take the antiderivative of 2x, you end up with x squared. And so there is that. And or if you take going the other way, if you take the derivative of this one, you end up with 2x. Now, we'll see some that are not quite that one-to-one, but there is a correspondence between the two. And so what we're going to do from this point, we have u equals 1 plus x squared. So then du equals 2x dx. And so before, when we take derivatives, a lot of times if you didn't use y prime, you might use dy over dx. So same idea here, du over dx, and then we just move the dx over here, or over here as the case is. All right, so here's our blue, and here is our red. And so now we have a nice, easy substitution. So the integral of 2x square root of 1 plus x squared dx equals the integral of square root of u, and then the 2x dx becomes du. So there is our blue, and there's our red. And now we can integrate this one pretty easily. So write this with an exponent if you like, u to the 1/2 du. Add 1 to the exponent, divide by the new exponent, we get 2/3 u to the 2/3 plus c. And then let's just substitute what u is back into this, and we get 2/3 times 1 plus x squared to the 2/3 plus c. And then that is the answer. And of course, like with all antiderivatives that you get, you can take the derivative of your answer and see if you end up with where you started. And so it's always a way that you can check these. So let's look at the next one. And similar Similar problem. I know we don't have a square root in this one. We have to the sixth, but it's still, if you think of a square root as being an exponent, it still is similar. So we have a blue part. Now, which part should be the blue part? Um, we have x to the fourth. We have x cubed. So which would be the derivative of the other? So x cubed is closer to the derivative of x to the fourth than vice versa. If you take the derivative of x cubed, you get x squared, 3x squared to be exact, but x squared. So this part will be the blue part. It'll be our u, and then the rest is the du. So everything should be underlined, either red or blue. And I would kind of suggest that you do this when you're first starting. Because especially some of these might get a little bit trickier. The first one is fairly basic and there's not too much else going on. But you'll see in this one that it's not as straightforward. It's not super complicated. Again, you don't worry about the sixth out here. So our function is x to the fourth plus 2. Our other function is x cubed. So u is x to the fourth plus 2. Du is the derivative of this. So 4x cubed dx. All right, so we have our blue right here. We have our red kind of right here. So we don't need that fourth or the 4. So let's divide both sides of the du equation by 4. So we have 1/4 du equals x cubed dx, and then that is our red that we need. All right, so now let's do the substitution. So integral x cubed times x to the fourth plus 2 to the sixth dx equals the integral, and we have x to the fourth. Now, probably on these, when you're doing the substitution, you're going to find the u part first and then do the du. Although I guess it doesn't matter, but you can't just say where is the x cubed. X cubed dx is all the same part, and then this is the other part. So x to the fourth plus 2 is u. We raise that to the sixth, so we have u to the sixth. And then x cubed dx is 1/4 du. And if we want to write that a little bit more nicely, we can do that. So now let's integrate. We will add 1 to the exponent, divide by the new exponent. So we get 1/28 u to the 7th plus c. And then u is x to the 4th plus 2. So we have 1/28 x to the 4th plus 2 to the 7th plus c. And that is what we get. All right, so same as the last one as far as what we're doing here. And let's go back to go to number 3. This one maybe looks a little bit differently because now we have a square root in the denominator. But no big deal. We can actually do this basically the same way as we've done the last two. So what would the blue part be? That would be the 1 minus x squared, 4x squared, and then the red part will be everything else. So the x dx. Don't worry about the square root. That will come into play later, but we don't need to use that in the substitution. So let u equal 1 minus 4x squared. Then du is negative 8x dx. And again, we have to adjust the du equation. So we only need x dx. So underline that, get that by itself. So let's divide by negative 8. And so we have negative 1/8 du equals x dx. All right, so there is our red part that we need. And there's our blue part, the 1 minus 4x squared. So let's do the substitution, and then we can integrate this. So x over square root 1 minus 4x squared dx integral. So let's take care of the u part first. So underneath we'll have the square root of u, 1 minus 4x squared, that's u, so it's just square root of u. And then x dx is negative 1/8 du. And so we can write this with the u having an exponent if it helps. So negative 1/8 u to the negative 1/2 du. All right, so now integrate. Take the antiderivative. We'll add 1 to the exponent, so negative 1/2 plus 1 is 1. Divide by the negative 1/2 plus 1 is 1/2. Divide by the new exponent, which is 1/2. So negative 1/8 divided by 1/2 is negative 1/4. And u to the 1/2. Or we could write that as a square root plus c. And we'll substitute back in. I'll change the 1/2 to an exponent. So we have negative 1/4 square root 1 minus 4x squared plus c. And that is it. Okay. All right. So hopefully that makes sense. Again, everything in the original needs to be either with the u or with the du. And so then when you do the substitution, all parts of that will be corresponding to either the red or the blue, the u and the du. All right, so last one in this video. So now we have an exponential. So let's see what would be the blue be, or the u. So again, we don't need to worry about the e. We just get the 5r squared as the u. And then the red is going to be the rest, the r, d, r. So let's let u equal 5r squared. All right, now once you get a little bit of experience with these, you can, if you're not sure what the u would be, you can try something, and you should pretty quickly see what doesn't work. So for instance, if we said let u equal e to the 5r squared, then what would du be? That would be e to the 5r squared times the derivative of 5r squared, which would be 10r. So now we have 10r e to the 5r squared. But the u would be that part, so we don't have another e. So now we have two e's, and we don't have enough. There's no way to get this looking the way it looks. So so that is not the way to go. And once you, and it doesn't take too much experience, but once you get a little bit of experience with these, if you aren't sure what the u is, you can try something and see if it works out nicely as far as the substitution goes. Because any of the substitutions that we're going to be doing, as far as manipulating the du is not going to be that complex to do. So so the red is the RDR, so we need to divide by the 10. So we get 1/10 du equals RDR. And then of course the 5r squared is the blue. All right, so we have integral r e to the 5r squared dr equals e to the 5r squared. That becomes e to the u. Let's write the integral, and then we e to the 5r squared. That's going to be e to the u. R dr, we have 1/10, and then du. Antiderivative of 1/10 e to the u is just 1/10 e to the u. plus C. And let's substitute back into U. So we have 1/10 e to the 5r squared plus C. All right, so hopefully you see the pattern. And in all the ones that we've done, the blue part is in the middle, and then the red part, so you have one part on each side of the blue. So um, I would not state that as a rule, but there are a lot of these do kind of work out that way, to where the blue comes in the middle, and then both parts on the end are the red parts or the DU parts. All right, so practice these. The more you practice them, the easier they will get.